Okay, in this video, we will try to apply whatever we learned in my previous videos regarding decision trees. Okay, and we will be applying those stuff in a dataset, very famous dataset called iris flower dataset. Okay, and we'll try to see how real classification happens. Okay, so this is very realistic dataset. So I thought I'll create a video for this one, and we will be using scikit learn for classification purpose in this video, and also we'll be using a graphical tool called graph to for the visualization purpose. Okay, so before we start, let me show you the iris flower dataset. Okay, so if I just go to Google iris dataset, if you just search on that one, okay, so you'll find this data set over there. So this is a very simplistic data set. Okay, and you can download the data folder and the data set description as well over there. Okay, I already downloaded somewhere. I think, yeah, this is the one, iris data and iris names over there. Okay, now if I just show you the data set over here, first we'll go to names over here. Okay, and if you see the point number 7, okay, this is regarding the attribute information we have. Okay, we have sepal length and width, we have petal length and width over here, and then we have 3 classes: iris, setosa, versicolor, and the Virginia. Okay, so now our job is to, based on this feature, we have to create a decision tree model which will basically predict this class. Okay, so now if you just see the data over here, I think it has 150 records, 50 samples over there. Okay, and with all these 3 varieties of iris flower. Okay, and with their corresponding sepal length, width, petal length, and width over there. Okay, so now I will be using Python 3 for that. Okay, with scikit learn. So we will be, that's why I already have Anaconda installed in my system, so I'll be using Spider for development purpose. Okay, so scikit-learn provides a method to load the iris dataset, as it is a very famous one. So that's why they have the out-of-the-box method to load this dataset. Okay, so to do that, what we need to do is, so we will first import it from sklearn. Okay, this is the scikit-learn base package. Okay, dot datasets. Okay, so they have this dataset, this one, import, okay, load underscore iris. Okay, so this is the package we will be using for loading the iris data. Okay, now just to see whether it is able to load the iris data or not, what I'll say is we will just see the iris data first. Okay, so load underscore iris, if we just call this method, it should load the iris data. So if I just print iris over here, okay, so it should be printing that data set over here. Okay, so let me see it over here. Okay, if you see, it's basically printing the whole data set. Okay, so now we have to only take, it's basically printing the data set as well as names. So if I just open my notepad plus plus, it has 2 components, right? Data and the names. Names has all the informations, like who has developed this particular data set, where it is used, what are the different attributes, and the summary statistics of the data, right? So it is loading the full. So what we need is the 2 things over here, is the data part, that means only the feature part, and the target part, right? Here it is my target variable, this is my target column over there, right, which we are going to predict. Correct? So the things we need is 2 things. One is, I'll just mention as x as iris dot data. Okay, so this will be only my features. Okay, and if I just write y equals to IRRS dot target, okay, so this will be my target variable. That means my prediction, I will be predicting that one. So if I just print this two stuff now, okay, x, and just to print y, okay, so we will print one by one just to understand what we are printing. So before that I'll just clear the console here. Okay, I'll just print, okay, I have to print x, print x here. Okay, so if you see, it's just only the feature values it is taking up, and if I just do print y, remove, clear console, print y, okay, so it is just the target variables in coded format, right? So that means 0 means it is basically pointing out to the iris setosa. Similarly, 1 means this one, and 2 means iris virginia. Okay, so virginica, I think, yeah. So this is just numerically coded values of that one. Okay, so we know how to access the iris data, as well as how to access its target variables or target values, as well as the feature values over there, right? Now we will try to build a model which will basically classify this one. Okay, so for that it is always good practice to know where to find stuff. Okay, so if I just go to scikit learn, okay, documentation, so they have really good documentation over there. I'll go to the classification part, as we are dealing with the classification problem, right? And I will directly go to our decision tree classification. Okay, so decision tree has lot of stuff. So mainly this is the classification part over there, right? So which one is the classifier class over here? If you see, this is the decision tree classifier, right? Is a class capable of performing a multi-class classification on a data set, right? So what we need to do is we need to basically import this decision tree classifier, right? And it is defined under tree. If you see the below example from sklearn import tree, and when it is creating an instance of the classifier, it is saying tree dot decision tree classifier, right? So we can do in similar way, or we can write something like this. Okay, we can write from sklearn dot tree, okay, import that decision tree classifier, right? So that's my classifier over here, right? So I'll just copy that one, and okay, it has to be decision tree classifier, right? So we have imported a decision tree classifier now. So we have to first we have to initialize the classifier first, right? So I'll just write tree underscore classifier equals to this decision tree classifier. Okay, this is how we will initialize, we will basically create a new instance of the class, right? So that's why we are basically initializing the classifier. Now we have to fit the data, this data, to our classifier first. Okay, so there is a method of this classifier has a method called fit. Okay, so I'll write it down, model equals to our tree classifier, okay, dot fit. Okay, so fit is a method. Now let us try to understand the fit. Okay, so if I just see the documentation over there, okay, so this decision tree classifier takes an input of two arrays, an array x, sparse or dense, of size n samples and n features, which we have already in our x, right? We have 150 samples and we have 4 features over there, right? So if I just go to notepad and see it. So till this point, this is this numerical values, all our data values, right? Feature values, right? We have 4 features and we have total 150 samples over here, right? And it also takes an array of y integer values belongs to the target variable, okay? Belongs to the class labels or target variable over there, okay? So for the fit method, we need to pass these two guys over there, okay? So I'll write fit, okay? So this is x comma y, okay? So these two things I have passed to the fit method to fit the model, okay? So now we have to visualize the model. Just let us see just whether it is running or not. Currently we will not be able to see anything over there except this print, which is basically printing our target variables, okay? So what we'll do, we will try to develop a method now, okay, by which we will visualize the model over there. As it is a decision tree, so we have lot of tools available to visualize it, okay? And one of the most important stuff is called graph viz, okay? So I will show you the very simplistic way to install graph viz in your system, okay? What you need to do is you need to go to their website. So I'll just go to Google, okay, graph viz for Windows. Let's say currently I am in Windows, so I just search for that one, okay? So this is their official website, okay? And this is open source project and it's really good one. So you can download their source code. So if you just go to download over here, okay? Now based on your operating system, you should download the package and install it. So for Windows, what I have done is I have just downloaded an installer and I just installed that MSI file, okay, in my system. Now I will go to my Anaconda prompt over here, okay? Anaconda prompt over here, and we just will install a package using pip install graph viz, okay? I already installed this particular package, so maybe it will tell me requirement already satisfied, okay? But for you it should be, if it is not installed previously, it should be able to install it successfully, okay? So after that one, if I just write over here, okay, import graph viz, graph viz, okay, we should be able to import it properly, okay? So if I just run it, it should not give me any error over here. It is not giving because this import is successful. Even if you see, the spider is also saying graph viz imported but unused, okay? So we imported graph viz. Now through graph viz, what we can do is we can basically render a data, okay, basically the dot data, that should be a dot format of data, okay, to make it create a PDF file or something, right, which will be used for visualization purpose, okay? So for that, first we have to create a dot file, okay? So to do that one, what you need to do is sklearn.tree has another package. So I'll just copy this one, .tree import export underscore graph viz, export underscore graph viz, okay? So that means this package will create a dot file over here, okay? So we will try to create the dot file now. We'll just try to write dot underscore data equals to this export graph viz method we will call, right? We will call with the classifier name, okay? And out file, currently we will give none, so out underscore file we will give none because we will be creating the file using our graph viz method, okay? So now feature names, this is another input over here called feature names, okay? So this feature names I have to give the iris feature names over there. So in iris, whatever this in load iris, okay, so there is a input called feature, feature feature underscore names over there. So it holds the feature names over there, and class names. Okay, so I'll be giving in similar way iris dot target names. Okay, so iris target names. Now field equals to true. Okay, that means I'll show you when the graph will be generated. Rounded, this is just these are the like how the graph will be created, that related functionality. Okay, true, true. Okay, and special underscore characters, okay, equals to true. So we created a dot file. So this, if you just call this one, it should create a dot file over there. Okay, so now what we'll do, we have to send this dot data to the graph_vis method. Okay, so I'll just create a variable called graph. Okay, I'll say graph_vis dot source, source equals to this dot data. Okay, this dot data, and we will now create that graph. Okay, so we'll just render the graph now. So now this graph, okay, dot render. Okay, so I'll here render means it will ask you for a file name over there. Okay, I'll just give a file name called iris. Okay, so it will create that file in the same directory where this Python file exists. Okay, so if I just run it and everything goes fine, it should be able to create this folder. Now I'll just go to over there, and this is the folder where my iris.py files are saved. And if you see it over here, it created a tree diagram over here, right? So this diagram we created from the data. Okay, and passing from the data we got it over here, using our model and the classifier. Okay, and using the feature names, right? And we just rendered that one using the graph_vis. Okay, we got this binary tree over here, right? Now if you see it, if you remember from my previous videos, right, when we talk about decision trees, each and every node will be subdivided based on certain conditions over here, right? So now if you see it, the condition or the criteria we decide based on by selecting a feature and a threshold value over there, right? And which feature will be chosen and what threshold value will be chosen, it based on lot of iterations over there, right? That means we have lot of methods like Gini, chi-square, information gain, right, to determine which feature and threshold value is the most optimal, right? Based on that, we will first divide that one, then we will divide the node again we will perform the same stuff to determine which feature will be applied. If you see here the root node, right, over there we have a sample of 150. So sample means, okay, let me just try to explain it over here. In the box, this is a node, right? Now based on which feature we are basically dividing this node, it's called petal width. Okay, we have this feature in our data set, right? And the threshold value is this one. That means whatever the petal width has, whatever flowers has petal width less than equals to 0.8, okay, we'll divide them into one box. The other flowers will go to the other box over here. If you see, there are total 150 samples, right? 50 samples go over there and rest of the 100 samples are going over here, right? Now the value, if you see this value, means how many samples I got for each and every category. That means if I just go to my notepad again, so these are my category variables, right? So 3 category variables we have, right? So we got 50 samples for each and every category. Okay, now when these conditions we are applying, if you see, we are also calculating a Gini value, right? So as I told you in a previous video, Gini is the most common algorithm to use for decision tree node decision. Okay, so if you see it over here, whenever we just do this one, right, this particular uh, this particular condition we applied for this node, we got a very pure node over here, right, for iris setosa over here. If you see, none of the other nodes have this iris setosa with Gini value 0. That means we can clearly say a flower with petal width less than equals to 0.8, okay, it is definitely a iris setosa. Okay, now if you see the right part of it, right, it's got a 100 rest of the 100 flowers over there, right? We are again dividing this node based on width, because maybe that width and this threshold combination having the lowest Gini value over there. Okay, so and again this value, how many flowers we are getting over there, and based on that one, each and every node, if you see it over here, we are splitting it up. Okay, and based on that condition, if you see, if you check the leaf nodes over here, right, all the leaf nodes have a Gini value 0. If you see it here, 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 and here, right, and each and every leaf node must have classify a particular class of that flower, right? Now if you see it over here, if you notice one stuff over here, okay, so first of all, we have only 150 examples, right, 150 samples over here, and the trees already grows 1 2 3 4 5 levels, right? So if you have more and 150 samples with only 4 features, right, so if you have more features and more samples, definitely this tree will grow much faster, right, and it will have much more levels over there, right? So we can say that this decision tree have a tendency, okay, this is very common to a decision tree, it has a tendency of overfitting the data. That means it will, for a very simple change, for a slightest change of the data, it will create a completely different tree at all. Okay, so we'll see in future videos how to overcome these challenges. Okay, but generating a complete tree, complete full-fledged working tree, okay, is a NP complete problem. That means maybe I'll say generating a optimal tree is a NP complete problem. That means we do not have any solution till now, proper solution till now, to generate a tree, optimal tree. Okay, so now you have your model over here, right? So if you got a new flower, based on that flower characteristic, you can determine. Now let me show you another good stuff over here. So based on some input, you can predict the probability of that class as well. Okay, so to do that, what we need to do is we will go to our spider. Okay, so we'll write something like this. Let's say probability. Okay, probability equals to tree underscore classifier. This is our classifier, right? So classifier dot predict proba. Okay, this is the prediction of the probability. Okay, so based on certain inputs over there, so that means we will be basically input a new flower values, petal length, petal width, sepal length, and sepal width, right? So if I just write something like 7, okay, sepal length is 7, sepal width is 3.3, okay, petal length is 4.5, okay, and petal width is 1.5. Okay, so let's see what it is predicting. Okay, so if I just print the probability over here, I'll just clear the console. Okay, right, and okay, let me see. Okay, I just open this file, so that's why it is not able to write it again. I'll just clear console. Okay, if you see, it's predicted 100% as 1. That means the second class, which is our versicolor, right? So, and if you see this PDF file, right? So let us try to go through it, reason through it. So this is sepal length. Now, okay, another important stuff I wanted to show you over here as well. If you see, most of the division happens either based on petal length, petal width, petal length. Okay, if you see sepal length, there is no place I think which we used for with sepal width. Okay, so this one, this is the sepal length, right, which is 7, and for this guy the petal length is 4.5 and the petal width is 1.5. so first is our petal length, right? It is less than 2.5, that means satosa no. So we are basically moving to this direction, which is, this is our, for our case it is 4.5, right? So we are moving to this guy over here. Now after this guy, if it is saying petal width is less than 1.75, for us petal width is 1.5, that means it is basically satisfying this condition. That means we are basically going to this node over here, right? Here again it is checking whether my petal length is less than 4.95 or not. It is again less than 4.95, right? So that means we are moving to this direction now, right? So again it is checking whether petal width is this one. So ultimately I think it will go to this 1.65 and ultimately it will predict versicolor, which it has predicted. It has predicted one versicolor. Okay, but that is how a decision tree works. Okay, now in next video what we will try to do is we will try to analyze the internal algorithm of the scikit learn. Okay, it uses a very special algorithm. We'll try to analyze that one, and also in future videos we will try to develop more graphics, more visualization related to the decision tree. Okay, one of them will be the tree diagram, okay, or the decision boundary, or basically scikit-learn follows a CART algorithm, CART algorithm. So we'll try to analyze that one. Okay, see you in next video.